Hello, I'm Savannah, and I will be showing you how to look at mass spec, IR, proton NMR, and carbon NMRs to analyze caffeine and see how these graphs reflect the structure of the molecule. Okay. So we'll begin with the molecular formula, which is C8H10 N4O2, and this is for caffeine, and its molar mass is 194. So that'll be important whenever figuring out your N plus peak. So this, since it's the tallest peak, it's the base peak, and it's also the M plus peak because it's at 194, which is the molecular mass of the caffeine molecule. So we can try to figure out if there's any other fragments in this, and you can do that by maybe subtracting this peak right here, which is 109, and you get 85, but that doesn't match with the formula, so we're going to ignore that number. And also, you can figure out the degrees of saturation in this part using the molar mass. So 2 times 8 carbons plus 2 plus 4 nitrogens minus 10 hydrogens minus 0 halogens over 2 equals 6. So that means there's going to be 6 rings or double bonds. Okay, so we start with zone 1, which is right in this area, and we have no dips below 50, so we're gonna ignore that region. There's no indication of any signals in that region. So then we'll go to zone 2, which is right here, and we have some dipping here, and so it basically in zone 2 and in zone 3, in just zone 2, we have an indication of an sp3 right here because it goes past the 3000 mark. So that means we're going to have some sp3 and also sp2 because of this maybe right here. So some double bonds in there as well. And so then we move to zone 3 and we have nothing there. And then zone 4 right here, nothing there. And then this final region is called the fingerprint region, and we have this signal right here, which means that there's a C double bond O is what these two dips mean. And then there's a signal here, which is right about the 1007 or 1,556, 1600 mark, and that could mean alkene stretching, which makes sense because we have some double bonds here that would explain that. And then also with this C double bond O, we have a lot of those as well. And then right here is a code for an aliphatic amine, which is C bonded to a nitrogen, and we see that here and here and here and here since we only have primary amines, so that's probably a signal for those primary amines right there. And that's all for IR. So this is called proton NMR, and so with these peaks right here, they all represent hydrogens. So we're going to label them 1, 2, 3, and 4. So this first peak is 3.395, and this matches up with this region of hydrogens right here. And these are the least deshielded because they're the farthest this way. So that means they're not deshielded as much as the other ones. So for number 2, we're going to label it as these hydrogens right here. next to this nitrogen. They're the second least deshielded, and that is at 3.574 ppm. And then we're going to label these 3.999, and that matches up with these hydrogens right here. And so they're a little more deshielded than these other ones right here. So this one's 1 and this one's 2. And then the last region of hydrogens is this hydrogen right here, the most deshielded, which is probably due to these two nitrogens and these two rings right here, shielding it from the rest of the molecule. And so that's going to be here, and that's at 7.527 ppm. And that's all. So the last graph that we're going to analyze is carbon NMR, and we're going to label these 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 peaks, and I'm going from left to right when I number them. And so I'm going to start with the first one, which is going to be here, which is the farthest down field, so that means it's the most electronegative, and that would make sense since it's bonded to this O right here. Number 2 is right here, also bonded to a nitrogen and has a double bond. The third one is going to be here, which is also the C double bond O, which would make sense. And the fourth one is over here, bonded to this nitrogen. So then these are all kind of grouped together, and then 5 is farther upfield, and 5 is right here, in the middle of these two. And then these are all clumped closer together upfield, and that is 6 right here, 7 over here, and 8, which is actually here. And if you notice, those are all methyls, which would make sense because they're the least deshielded from each other. So that's why they're more closer down or upfield. And that is all for the graphs and caffeine, and that is how you determine how the structure is reflected in these graphs. Thank you.